Hello guys, my name is Bob. In this video I am going to show you how to solve the problems of the Maclaurin series of cosine x using the top right hand corners formula. So the top right hand corners formula tells us that a function can be expressed as an infinite series called the Maclaurin series, in which each term is has the following general form, which is x to the power of n, f to the power of n0 over n factorial, where f to the power of n0 means that differentiating from the function n times and evaluating at x equals to 0. But before I solve this video, do help me to press the subscribe button if you guys like to see more integration problems and Maclaurin series problems, and also help me press the like button icon if you guys like the solution. Now let me begin by solving the problem. So before we are able to find what is the Maclaurin series of cosine x, we need to find out the following, which is f0, which is the function evaluated at x equals to 0, f10, that means the function differentiated one time and evaluating at x equals to 0, f20 is the function differentiated twice and then we find the value at x equals to 0. f30 is differentiating the function 3 times and finding the value at x equals to 0. f40 is differentiating the function 4 times and then we find the value by making x is equal to 0. So now let's find out what is our fx. My fx is cosine x, and we're going to find all the differentiated functions. So when we differentiate the function one time, we will get a negative sine x. We differentiate the function 2 times, we will get negative cosine x, and if we were to differentiate the function 3 times, we will get sine x, and when we differentiate the function 4 times, we will get cosine x. Alright, and now once we found all the differentiated functions, we next find the values at which x is equal to 0. So f0 is basically equal to cosine 0, which is 1. f10 is basically equal to negative sine 0, which is equals to 0, because sine 0 is 0, so negative 0 is definitely 0. And f20 is negative cosine 0, because cosine 0 is 1, so negative cosine 0 is negative 1. f30 is sine 0 is basically just 0. And cosine 0, that's for f40, so that will be equals to 1. So now once we find all the functions evaluated at x equals to 0, we can express the function, which is the cosine x, up to and including the x to the power of 4 terms. So the first term is f0 is just 1. The second term is x times f10 is 0. Alright, so actually the second term is basically just 0. f20 is basically negative 1. So the third term will be x squared times negative 1 over 2 factorial. How about the fourth term? The fourth term is x cubed 0 over 3 factorial. While the fifth term is x4, f to the power of 40 is 1 over 4 factorial. And for this one is actually, for this equal sign is actually not an equal sign but an approximate sign, because we are approximating the function using the Maclaurin series and expressing it up to and including the term x to the power of 4. Hence this part here should be an approximate sign. Last but not least, we further simplify the equation. We will get 1, the second term is 0, the third term is negative x squared over 2 factorial. The fourth term is 0, fifth term is x to the power of 4 over 4 factorial. Alright, and this is the final answer of the Maclaurin series of cosine x. If you guys do like this solution, press the like button, and don't forget to subscribe to this channel for more integration problems, Maclaurin series problems. My name is Bob, thank you guys for watching, and I will see you in the next video.